Yes, class. Good evening. Am I audible?
Good evening, ma'am.
Good evening, ma'am. Yes, you are audible.
Okay. What's your name? Who has entered with this mobile phone Galaxy J24?
Waziha.
Okay, Wazia. Okay. All right. So this is Talha and Yusuf M. News. All right. Fine. C class. We are currently doing laws of motion. So in laws of motion, we have completed some of the topics of laws of motion already. We have completed with the Newton's three laws of motion. The topic friction has been over. Now we are going to start with circular motion. Circular motion is one of the major topics of laws of motion. So it's a completely new topic. And whatever older topic will be used, that time I'll introduce you the topic. And regarding the backup timings, we'll discuss it well. Aisha, do you want to say something? Aisha. All right, okay. See, we had discussed two concepts over here. See, when we deal with circular motion or any kind of motion, we have two major parts of it. This we had discussed it, so many students were not there in the last class. So let's see. Friction C class. Friction we have completed. So we have to have a class on friction and the Newton's laws. With only Waziha, I have discussed the Newton's laws of motion. For the rest of the students, laws of motion, the Newton's three laws are also remaining. Then we had completed with friction. C class. When we start with circular motion, no, we have had this concept done already. There are two things that are dealt whenever motion is done. One is kinematics, one is dynamics. In general motion also, not specifically if I talk about circular motion. In general also, if we talk about motion, we talk about kinematics of motion and dynamics of motion. The kinematics you must have heard of, that the lessons that we have, motion in a straight line, motion in a plane, all these are considered within kinematics. Why do we say these are considered as kinematics of motion? They are considered as kinematics of motion because these are just dealing with the motion. They are not concerned with any of the factors that are related with why the motion is occurring. They are just concerned with the fact that yes, motion is occurring. We do not consider, see, when we did chapter number 3 and 4. Okay, before that, class, just tell me what, except for Waziha, only Wazihas I know. Talha, you let me know what is the physics current lesson going in your school. Talha?
Laws of motion.
Laws of motion is only going. All right. And Yusuf?
The same chapter, ma'am.
The same chapter is going. All right, fine. Okay, then no issues. All the chapters that has been missed. See, chapter number 3 is back up also. I have discussed this with Waziha. I'll discuss it with all of you also. That we can discuss for the backup timings because this is an important lesson class. This lesson, projectile motion, all these chapters of mechanics, no, these are concept core lessons of yours. So without their understanding the other concepts become very difficult. Fine. So since circular motion is a new topic, so that's why we can begin from here. But we have to complete the previous backups, that is the friction and the Newton's three laws. So that are not very lengthy, that are short. And regarding the previous lessons, angular motion and horizontal motion is there under projectile motion. So that is also not lengthy or difficult. So that will also be covered. So see, yes, as I was discussing kinematics and dynamics. Dynamics deals with the cause of motion. We deal till chapter number 4, that is your motion in a straight line and projectile motion. We deal with that an object is in motion. We have studied this also, that a projectile has been thrown up or a ball has been dropped or a car has started moving. We did not consider the fact why did the car move, or if the car moved, what was pushing the car, how was the car moving. All these why and how are dealt in laws of motion, because laws of motion is not kinematics, it is dynamics. It deals with the cause of motion. Yes, a car is moving. The frictional force will act in the backwards direction of the motion. A forward push will be given to the car so that it will move. A normal reaction will be exerted on the ground. The weight of the car will be exerted in downwards direction, and all these things. So similarly, if we deal with circular motion as well, we have to consider the kinematics and dynamics. Fine. So if we start with kinematics of circular motion, this will be somewhat analogous to what you have studied for linear motion. All the terms that were involved in case of linear motion, they will be repeating in case of circular motion. So we can have a revision also of the terms that we have already studied for this. All right. Now see, when we deal with the circular motion, kinematics of circular motion, the first term that comes is angular displacement. The first term that is involved over here, this is angular displacement. Fine. So linear, Aisha, your network is fine? Aisha, are you able to hear? Okay, that's good. Fine. So yes, so first, the very first term that comes is angular displacement. Why? Even if we study linear motion, the very basic thing that we study about linear motion is what? Displacement, distance or displacement. Right now we are dealing with displacement as it's a vector quantity. I hope you all know the difference between scalars and vectors. All the students who are new and who are not aware of the terms, just let me know. I'll repeat whatever term you have not understood. It's okay even if it's a very basic term. You all are in class 11. I'll repeat it for you. So yes, angular displacement. First, let us revise what was linear displacement. Linear displacement was what? It was the shortest path that was covered between the initial and final point. If you simply join the initial and final points, you could obtain what? You could obtain the displacement. Similarly, in term, now we'll be dealing with angular displacement. So everything will be in terms of angle. For example, if I draw a circular path, circular motion has been covered. Certain parameters will be there, radius of the circle will be there. For example, I have started at point A, this point A that you are able to observe, I have started the point A. Now, I have covered circular motion. Notice this, the circumference or the boundary for it. I have started moving, I have started moving. Now what is happening? At this particular point, radius will be the same because it's a circle. I have not drawn it properly, but this is a circle, a proper circle. So at this point, if I am stopping, this is point, this is my final point. So angular displacement means the change in the angular position. Now you will not consider the fact or the displacement between A and B. If you join these two, this gives you the linear displacement. This is the shortest distance that is available. This is the linear displacement. Abdullah, it's audible to you? Abdullah?
Yes, ma'am.
All right. Now we are going to consider, since we are dealing with angular displacement, you just have to see what? Change in the angular position. So it means this is the change in the angle that has arisen. Some theta might be there. This we call as the angular displacement. For your understanding, what do we say? Simply, in simple terms, if you have to remember, no, definition we'll do, angle served by the radius, that we'll do. But for your understanding, what is angular displacement? Simply the change in the angular position, whatever be the initial or final point. You're not concerned with the periphery now, you are concerned with the angle only. So this is what? This is change in angular position. This is the change in the angular position. Now, a proper definition. Change in angular position, this is for all of us to remember whenever you're revising. And a class, for the new students who are attending their first class, do not copy it right now. I give sufficient time to note it down. After I've discussed certain 1 or 2 topics, I'll give you ample time so you can easily write it down. Just listen first. Now the definition, the main definition, how will you write this? It's the angle that is swept by the radius, right? It is actually the angle that is swept by the radius. So angle swept by the radius in the angular position. So angular displacement will be angle swept by radius. See, in your exam, nobody is directly going to ask you the definitions of angular displacement. But angular displacement has a very major significance, especially when we'll move on to rotational physics. By radius vector is angular position. This is known as the angular position or angular displacement. SI unit is very important because now the SI unit is not meters. Displacement's SI unit was meters. The SI unit for this is radian. And please pay attention to the SI unit because you must have heard or done motion in a straight line in your schools and all. So SI unit was meter. Did you notice when you reach to velocity, meter per second, then when you reach to acceleration, it became meter per second square, and so on the units catched up. Why? Because when all of these had the basic unit as displacement, so the formulas also included displacement. Similarly, here also you will be including angular displacements as well. So if you include angular displacements as well, then importance of radian comes. So again, this will be caught up back. The SI unit is radius, and one more thing, it's a vector. Definitely it's displacement, so it will be a vector. Okay, Abdullah, I have noted. I'll get it. So yes, because you didn't also, I think, receive the marks also because you were not on the group. So I had sent the scores of the last test as well. Yes, it's a vector that we all know because definitely displacement is there. So displacement is a vector. But one thing that will be additional over here, that it is an axial vector. Let's discuss axial vector. We have not discussed axial vector before. Axial vector is simply a vector. Group use of, yes, actually there's a WhatsApp group as well for both girls and boys separately. So tests also are conducted. So the sheets are submitted on the group. Any update regarding the class, the marks of the test that are shared. So that will get added once you have the class. Abdullah was sharing about that group only. So yes, axial vector. So axial vector, what you have to remember about axial vector is that everything regarding all the points regarding a vector is same, but it's just that its axis or its direction is along the axis of rotation. For example, this is basically used in rotational effect. Never use axial vector for your linear displacement. This is used for your rotational effect. Now, one thing you have to remember for axial vector specifically, direction is along axis of rotation. Now, what is meant by this? Direction is along axis of rotation. It means, suppose this is the motion. This is what? This is clockwise. So let's say this clockwise is the direction of motion. But if I say a particular vector is axial vector, then I'll say the direction is towards this axis. If the rotational axis is this, main axis is this, and the circular motion is occurring around this axis. This is my axis, and along this only the rotation or the circular motion is occurring. Then direction will be pointing towards this axis of rotation. This is the speciality about axial vectors, and axial vectors will be used in case of your angular motion, because right now we have to have these parameters. Now, one more thing, class, if you understand these parameters here only, no, then this becomes easier when we deal with rotational physics. In reality, in rotational physics, these topics are included, but we have to do it in circular motion because angular velocity, angular acceleration, some of the terms that are part of your laws of motion, and a complete circular motion topic, not only specifically from your laws of motion, a complete circular motion that is provided in your syllabus that we are covering here. That's why. Before we move on to further, do one thing. Note down, these are very small points. Few points are there, 1 or 2 points. Note this down. Then we'll discuss angular velocity. If you have any doubts in between, you can text me. I'm here. We can discuss it. Whatever doubts you have, any queries if you have from any of the point whenever you note it. Done till here? Yes, class, written? Or are you still writing?
Done, ma'am.
Done.
Done? All right. If anybody is writing, just stop me or text me. I'll scroll up back. Now, see, this was angular displacement, a very basic topic, a very short topic. Now, the questions that will come will not be directly from, we'll do numericals in today's class only. So they'll not be directly from your angular displacement. They'll be in combination with angular velocity that we do. Now, angular velocity is not difficult to study. If angular displacement is understood by all of you, then angular velocity is not done. See, what is linear velocity? The normal velocity that deal with. If displacement is there, then whatever is the rate of change of displacement, whatever is the rate of change of displacement. Rate of change of displacement means displacement that is changing with respect to time. Whatever is the amount of displacement that is changing with respect to time. This is known as rate of change of displacement. So velocity is simply rate of change of displacement. Here also, angular velocity. One more thing, class. This depiction of this, how to denote angular displacement. Angular displacement is denoted by theta because it's a change in angle simply. That's why it is denoted by theta. Add it into your notes wherever you're writing. It's just denotion is by theta. So similarly, angular velocity will be what? It will be angular change of displacement, rate of change of angular displacement. Linear velocity was rate of change of linear displacement. This becomes rate of change of angular displacement. Rate of change of angular displacement means what? Amount of angle that is swept by the radius per unit time. This is denoted by this symbol omega. We call this, it is similar to the letter alphabet W, and this is denoted, this we call it as omega. So omega is rate of change of displacement, means change in the displacement by change in the time. So this you can simply say angular displacement. This is angular displacement per unit time. This is the formula for it. Or if you have, see, this is the main formula. Now when to use this formula, how to use it, that we'll study. Because see, one more thing. Two things will be similar. It is an axial vector. It means its direction will be along the axis of rotation. And how to write the direction, how to specify this axial vector, that we'll see with the aid of questions only. Right now only when we do the questions. SI unit, can anybody answer? If this is the formula, then what should be the SI unit of it? Anyone from the class? Angular displacements unit we have done. Times SI unit, I hope all of you must be aware of. So omega's angular velocity is SI unit should be?
Radian per second.
Newton meter.
No, see, angular displacement is, you have to relate it with the formula. So angular displacement is what? Angular displacement is simply radian. So if angular displacement is radian and this is time, so this becomes what? Radian by time, and times SI unit is seconds. So this combines and gives you radian per second. The way for velocity, it was meter per second because displacements was meter. So meter per second, rotational analog, radian per second, because radian is it for the angular displacement. Clear? Now see, angular velocity, we'll not be studying it in one go because angular velocity, no, how to use this in the formulas and all. Angular velocity is dealt in two columns. One is your uniform angular velocity. Another one is simply non-uniform. Non-uniform angular velocity. So you have to remember how to remember which one is uniform and which one is non-uniform. If that magnitude and direction both are constant, two things. Magnitude of the velocity, magnitude, I hope you understand, the term without which you have without the signs that you have. Fine, the term that you have without the signs. For example, some force is -3 Newton. So only the number 3, that is the magnitude. You ignore the signs whenever we are dealing with the magnitude. So for uniform or for an angular velocity to be said as uniform, we have to have both its magnitude and direction and the direction of velocity. Velocity means your angular velocity. These are constant. These are constant means, for example, some at this point angular velocity is 2 radian per second. Fine. So it means at this point also angular velocity will be 2 radian per second only, and direction will be along the direct axis of rotation. So this type of velocity is known as uniform angular velocity. If it was 2 radian per second, it was 2 radian per second throughout the entire journey. But in case of non-uniform, either of these quantities, either it can be magnitude or it can be direction, any one from it. If it is not constant, if it changes with respect to time, then you call it as non-uniform. Any of the quantities, whether it's the magnitude or it's the direction of it. So it's either magnitude or direction, or it can also happen both. It's not necessary that only one thing out of both should not be variable. Both of these can also be variable, or both change with time. For example, this was a circular path. At this point, omega was 2 radian per second, but as this point was arrived, this increased, omega increased. Again, the point arise, omega decreased. So this variation, this is a variation in magnitude. Direction could be constant, direction could be variable. That will be dealt for separate cases. Understood? So you have to understand in terms of these two quantities only. Now, when we deal with non-uniform part, no, non-uniform has something, because uniform is constant. Whatever is the magnitude of angular displacement divided by time, you will get the value of omega. So nothing new, nothing difficult, how to choose. But in case of non-uniform, you have to have two kinds of formula. For uniform, it's fixed. Angular displacement divided by time. Just try to find out angular displacement and divide it by time, you will get uniform if it's uniform. If you see it is non-uniform means you are able to observe that this varies with time. This we'll discuss when we'll see questions. We'll try to figure it out whether it's uniform or non-uniform. Now, if we suspect that it's non-uniform, then two formula can be used. Omega can be delta theta by delta t. This is if you have specific duration. For specific duration, for example, 2 hours, or from 2 p.m. to 4 p.m. Or you can say t is equal to 2 to t is equal to 8 seconds, or 4 to 8 seconds. Like this, if you have specific duration, then you can easily use this formula, and the type of velocity you will obtain, this will be called as average angular velocity. Fine. Now, if you are able to observe certain equation is there, for example, theta is 3t square plus 4 like this, and you're able to observe there is no time duration given. Particular time instant is mentioned, that calculate the angular velocity exactly at t is equal to 5 seconds, or calculate the angular velocity exactly at 3.001 seconds. Like this, you have the velocities with you exactly at a particular time instant, 3.00001 seconds, like this, a specific, or exactly at 4 p.m. calculate the angular velocity. When no duration is given, a specific time instant is mentioned, then you differentiate it, d theta over dt. I hope you all are clear with differentiation. If you have any doubts in differentiation, we can arrange a revision class also for differentiation, because differentiation is a very basic thing that we require. So if you all want, we can have, for the new students, we can have a class on differentiation and integration. Now, this type of angular velocity that will be obtained, this is simply known as instantaneous angular velocity. This is known as instantaneous angular velocity. Here, at a specific time instant, you are calculating the angular velocity. So angular velocity, we have categorized it into uniform, non-uniform. Uniform, where nothing is changing, its magnitude, direction, everything is constant. Then we have non-uniform. If time duration is given, we require average angular velocity. We simply divide the change in the displacement by the change in the time. And then we have, if a specific time instant is given, then we differentiate it and keep the value of the specific time that is mentioned. So only this part is in one more thing, class. One relation is there. Let's do that. Then you can note it down. There is one relation between the linear velocity that we study and angular velocity. That is also used a lot in numericals. Numericals also, as well as in your theoretical questions also, you will be requiring that relation. So it's a relation between angular and linear velocity. See, class, a circular motion is being done. This is our radius. The vector, the radius is small r. Fine. Radius is smaller. Now, angular velocity, as I've told you, its direction is along the axis of motion. So this is the rotating axis. So let's say direction of omega is here. Fine. And linear velocity, we have already done this also, and I'm repeating this. This is the direction is tangential to the circular motion. So this was the circular motion, it will be tangential to it. Now see, if this is tangential to it, so every point the velocity, linear velocity will be tangential. Relation that combines, or a formula that unites linear velocity and angular velocity as well as radius is simply this formula. V is the cross product of omega and r. V is equal to omega cross r. Cross product and dot product have already been covered in this class. So we can again have a backup class for that as well. So on Wednesday's class, we'll discuss about the timings of backup and everything. On Wednesday also you have a class, same timings. So this small v is what? Small v is the linear velocity. Fine. Omega is what? Omega is the angular velocity. And while r is what? R is simply the radius vector. This formula you have to remember. And can anybody tell me, if we open the cross product, what trigonometric component do we get? Sine or cos?
Sine?
Sine. Exactly. Yes, it is sine. Correct. Was answered this, Talha? Yusuf.
Yeah, ma'am.
Yusuf. Okay. Yes, correct. See, we take the magnitude of the first vector, we take the magnitude of the second vector, and we put sine theta, and theta is the angle between both the vectors. Had it been dot product, the way we had the formula for work done, and in many other cases we have dot product. There we use cos theta, magnitude of first vector, magnitude of second vector, and cosine of the angle between them. That is cos theta. When we have cross product, if you see a cross in the formula, you take the magnitude of first, magnitude of second, and put sine theta. Now see, angle between omega and r, both are perpendicular. Omega's direction is along the rotational axis, while the radius is along the circular path. So both are making an angle of 90 degree over here. That's why if you put V as omega r sine 90 degree, final relation that you will obtain here, this will be simply V is equal to omega r. Just in case if you see they are not perpendicular to each other, there can be. So simply use omega r sine theta, omega across r you will use. And remember, linear, this velocities is tangential. Linear velocity is tangential. Fine. This is the theory part. Now, major part is in the numericals. We'll do numericals. First element. Is it clear till here to all of you? Aisha, Abdullah, Talha, Waziha, Yusuf?
Yes,
Yes.
ma'am.
All right then. Okay. So do one thing. Start noting down from here. If at any point you're not able to understand, let me know. I'll clarify the doubt. So till here, no, from here you have to write. Then we'll do the numericals part. This is a part of non-uniform only. This one. No, see, here you will be having two values of displacement. There will be initial and final displacement. So change in the displacement, you can calculate final minus initial. Same thing with the time. Time also final time minus initial. C class, let's do a numerical. This says that a body moving on circular track completes 10 revolutions. So body completes 10 revolutions. Revolution means, see, this is rotation. And this is around an axis. If you move, this is known as revolution. So body completes complete revolutions, 10 revolutions. And the time taken over here is 5 seconds. So 10 revolutions is important for you and 5 seconds. Radius of the track is 2 meters. You have to calculate the angular velocity. And if you have calculated angular velocity, then with the help of radius, you will be able to find out linear velocity. But first, we have to find out angular velocity. C class, certain conversions we'll do. See, 1 revolution, no, we have to convert it in terms of radian. How will you use theta? This is basically angular displacement. 10 revolutions mean this is the angular displacement, but this is not the SI unit. SI unit term is in terms of radian. So we do not have it in terms of radian. So we have to perform certain conversions. It's like the way we convert kilometer per hour into meter per second in this way only. So 1 revolution means 360 degree. If 1 revolution has been covered, it means 360 degree. We write 360 degree as 2 pi radian. Understood till here? Simple conversions. Okay, because you will be requiring these conversions in any, not even till your for 11th class, for 12th class as well. So 1 complete revolution, this is 360 degree, we call it as 2 pi radian. Fine. So if you have 10 revolutions, so for 1 revolution, it was 2 pi radian. So for 10 revolution, it becomes 2 pi into 10. That gives 20 pi radian. Got it? This conversion, because this is important class. Now the question is easier. Change in displacement by change in time. Total displacement or the change is given to us as 20 pi radian. And the time is given as 5 seconds, right? I think it's given as in 5 seconds, exactly. So this is given in 5 seconds. So this becomes 4 pi radian per second. If you wish, you can put in the value of pi as well, 3.14. You will get the answer approximately 12.56 radian per second. 4 into 3 is 12, so around 12.56, this will be the answer. The precise answer I don't remember. Now, radius of the track is given to us as 2 meters, right? Radius is given as 2 meters. Linear velocity is asked. If we know angular velocity, we can easily calculate linear velocity. We have done V is omega. So V will be omega is, let's say, 12.56, R is 2. So this becomes approximately 25, 24 something. So 25 point, this is 212, 25.12. Now SI unit will be meter per second. This is not your angular velocity. This is linear velocity. Got it? This is a very easy formula based question. The thing that you have to remember over here is this part. This is important. If I note down this question and the solution, we'll do some more numericals. Any part you have not understood, again, I'm repeating, you can text me like other students text. In the chat box also you can text. I'll repeat it. If you want, you can unmute yourself and also ask. Yes, the concept of angular velocity, or within this question, the first part. Just the first part of this or the topic angular velocity?
The first part, ma'am.
The first part. Okay. See, 10 revolutions are there. A track is there. On this circular track, 10 revolutions have been completed. 10 revolution means 10 revolution simply means you have a circle. See, a circle is there. Fine. This is the center of the circle. Now, within this, from this point, somebody has started the journey. The person has reached this point back. It means the complete 360-degree angle has been made. We call this as one revolution. In terms of degree, we say 360-degree. And in terms of radian, we say pi, 2 pi, because pi is 180 degrees. So 2 pi becomes 360 degrees. Fine, so this is 2 pi. Then the person does not stop over here. He completes 2 revolutions. So that means 2 pi plus 2 pi, 4 pi. Then again, like this, 10 revolutions have been completed. So complete displacement is 20 pi radian. So that is the complete displacement. Now, if displacement is 20 pi, so we have obtained the displacement. Time is given as 5 seconds. So displacement divided by time. 20 pi divided by 5 seconds gives omega. That is your angular velocity. Clear?
Clear, ma'am. Thank you.
C class, it says calculate angular velocity of rotation of Earth, and no other data has been given to you. So simply, if Earth is there, it is rotating. This angular velocity we have to calculate. See, in one rotation of Earth, when Earth completes one rotation, how much angle will be covered in one rotation of Earth? Can anybody guess how much angle will be covered? One complete rotation of Earth. The Earth from where, yes, Yusuf,
360 degree.
360 degree, perfect. So in one rotation of Earth, this is 360 degree or simple 2 pi radian in terms of radian, because degrees is not the SI unit. So we'll be writing in terms of, in one rotation of Earth, that delta theta, that is rightly answered by Yusuf, this is 2 pi radians. Fine. Now you have theta with you. Now regarding time, in one rotation of Earth, how many hours do we have, or what is the time duration we say for one rotation of Earth? That everybody knows? Yes, class. How many hours are there in one rotation of Earth? Yes, Aisha?
24.
24. One rotation means one day. One day has 24 hours. So this is 24 hours. So definitely we'll convert 24 hours into minutes, into seconds to get our answer in seconds. Now we have the SI unit, everything in terms of SI unit. This you can even calculate later on. This is delta theta by delta t. This will be 2 pi by 24 into 60 into 60 radian per second. This you can solve later and see whatever is the answer. Answer should be in terms, the number should be 7 something, 0.0007, like this you will obtain. You can do the calculation and check. Okay, note this down. One last numerical bit, then we'll stop the class. Quickly note this question. This you can calculate and check on later. See, one last question. Theta is given as 3t square plus 2t plus 1. This much amount of radian is given to us. We are asked to calculate angular velocity first part for 0 to 2 seconds, second part at t is equal to 2 seconds. So all those students who are not well with differentiation, we'll revise it later on. Right now, let's focus on this. See, theta depends upon t. If you change the value of time, theta will get changed. If you write theta t as 1, you will get theta's value different. If you write t as 2, you will get the value of theta is different. So it means this is non-uniform. Otherwise, we were dealing with uniform. Right now, this is non-uniform. So for the first part, this is a complete time duration is given to you. See, this is time duration from 0 to 2 seconds. This is a complete time duration that is given. So for time duration, what we have studied, we calculate the average displacement, average velocity, average angular velocity. So theta final will be at 2 seconds because the final time is 2 seconds. So put 2 everywhere. This becomes 3 into 2 square plus 2 into 2 plus 1. So this becomes what? 17, 4, and 12, 14, 16, 17. Then initial theta. Initial will be at 0 seconds. This is the initial time, no? So put 0 everywhere. This becomes 0 square plus 2 into 0 square plus 1. That gives you only 1 is there. Regarding the time duration is from 0 to 2 seconds. That is 2. So see, omega will be theta final minus theta initial by final time minus initial time. So final theta is 17 minus initial theta is 1 and final time is 2, initial time is 0. So this becomes 16 by 2, which is 8 radian per second. First, tell me, first part is clear to all of you? Any doubts in the first part? Clear?
Yes,
No,
ma'am.
ma'am.
Yes, Waziha. Should I repeat it once?
Ma'am, how we calculate the theta
See.
final and theta initial?
See, this equation is given to us 3t square plus 2t plus 1. It means whatever value of time you will put, at that value of time, you will get the value of theta. So we know it's from 0 to 2 seconds. From 0 to 2 seconds. It means this is the initial time and this is the final time. So if we have to get the initial theta I, we'll put 0 in terms of instead of t. So it was 3t square. So if you put t as 0, if I put at t as 0, I'll get this 3 into 0 square plus 2 into 0, not 0 square, 2 into 0 plus 1. For theta final, I have final time as 2 seconds because it is from 0 to 2 seconds. So I'll put the value of t as 2 seconds. जहां जहां पर टाइम की वैल्यू गिवन है वहां टूर की वैल्यू रख दो. So what will happen? 3t square plus 2t plus 1 is there. So wherever final time is 2, I'll keep the value of 2 to get the final theta. So that's how I have obtained 17 here and I have obtained 1 here because the equation was already given in the question. Clear? Waziha? Okay. If you have any doubts, Wazia, let me know. I'll repeat it. Second part says at t is equal to 2 seconds. Now, at t is equal to 2 seconds means exactly at a time instant we are calculating. For 2 seconds, we'll differentiate theta with respect to time. So we have to differentiate what equation? Theta is given as 3t square plus 2t plus 1. Now we have to differentiate this. So Talha, can we start with you? Can you differentiate 3t square? Talha?
Yes, ma'am.
Can you differentiate 3t square?
Ma'am, I still have doubt
In differentiate. Okay. So we have to have a class on differentiation. See, if any variable is x to the power n, because now so much time is not left, otherwise I would have revised differentiation. If any quantity is x to the power n, this becomes nx to the power n minus 1. This I'll discuss in detail. So, and what about you, Yusuf? Are you clear with differentiation and integration?
No, ma'am, you have to, I think, teach differentiation.
Differentiation. And Waziha, what about you?
No, ma'am.
Okay. Then I think this part will be difficult for all of you if you have not understood differentiation. We'll have a proper class for differentiation. We'll discuss it on Wednesday timings. After Wednesday's class, integration and differentiation are very basics for physics, not only for this part, for all the lessons. Fine. See, this is the basic thing how we differentiate. Right now I'm telling it in brief. So if it x to the power n, t to the power 2, you write the power first and write whatever is the power minus 1. That is t to the power 2 was here, so it becomes 2 minus 1, that is 1. And then multiplied with the constant term that was given. I think by this you'll not be able to understand. We have to study it in detail, but for this question, meanwhile, you can note it down. Then again, this is 2 is a constant, t to the power 1. 1 minus 1 will give you 0. So t to the power 0 is 1, no need to write t. And for any constant number, we have it as 0. So you are left with 60 plus 2. How we have obtained 60 plus 2, we'll discuss it in detail for the students who have not attended the classes. Fine. Right now, understand if on differentiation we are getting 60 plus 2, what you can understand at this point is if at t is equal to 2 seconds, this is asked, we can write now the value of t as 2 in this equation and we'll get it as 14 radian per second. It can happen. Second part might not be, you will not be able to understand. Just note it down for the time being till we cover this differentiation and integration. So note this down. At least first part you should be able to do. And second part, steps you should understand. This, yes, we are differentiating here and why are we differentiating here? Okay, quickly note it down. And just text me done in the chat box when you have completed it. Then I'll stop the class.